All right. Are we ready?
I was born ready.
Okay.
All right. I will.
Man, you got to check your fillings.
I'm going to stop. I'm going to stop touching all the things around here. Less noise, more podcasting.
Yes. Welcome to I Used to Know. I'm Scott.
And I'm Steve,
We're your hosts for this adventure into the past.
where we dive into things we used to know when we were kids that are no
longer true.
Hey, Scott.
Hey, Steve.
You know, Scott, back when we were growing up, we would bike back and forth to each other's house. Remember that?
Oh, yeah.
Yeah, and it was really easy because we lived pretty close to each other.
Yeah, just around the bend.
Yeah, around the bend. Do you know exactly how close we lived?
I don't know. Maybe a half mile?
Close. All right, close. According to Google Map, I just pulled this up. It's about 0.6 miles.
Oh, so I'm 0.1 off.
Or 20%. Think about it that way.
All right.
Right.
Physicist.
Yeah. So how far? Let's see. The Krauser store.
Oh, the convenience store.
Yeah.
Krausers.
It was out at the other end of the lake.
Yeah, it was at the end of the driveway, end of the big road.
Mhm.
So that was like about a mile.
Yeah, 1.2 miles according to Google. Again, 20% off. Yeah, you're kind of consistent.
That's my curve, my margin of error.
All right, so we go 1.2 miles on our bikes, and we would go there to buy
Lottery tickets.
no, come on, lottery tickets. This is back when we were kids. We're not getting lottery tickets when we were kids.
Right. We weren't getting lottery tickets.
Wink, wink.
Yeah. No. All right. So I don't know. Milk. We used to get milk. I'd get a gallon of milk.
A gallon of milk, exactly. And then you might be picking up maybe some soda. And then how much soda would you get?
2-liter bottles.
Yeah, exactly.
So where are you going with this?
Well, you said miles, right?
Yeah.
And you said gallons. And then
Right.
for soda, he said liters, right? Liter.
And like I said, where are you going with this?
Do you remember where the liters came from? It was from the time when our teachers were telling us that over and over, we better get ready. We better buckle down and learn this new thing called the metric system. Because someday soon, the United States is going to fall in line with everybody else in the world, and we're going to adopt the metric units for everything. It wasn't just going to be soda. It was going to be everything.
I totally remember that. Oh my God, yeah. I remember going around and gas pumps used to have the gallons on the top, and then right below they'd have liters.
Yeah, that's right.
Right?
Both of them.
Yep. And then the banks, right? They had those clocks that would be outside on the bank, right? And they'd tell you the time, and then it would say time and temperature. And it was like time, temperature in Fahrenheit, and then it would be temperature in Celsius.
Like, what is that?
And you'd be like, what is the C? I have no idea what we're talking about here. I even remember seeing in the mid-'70s, I remember some speed limit signs would have, and it wasn't even near necessarily Canada. It was like you'd see miles per hour, and then below it, it was like this almost like subtitle. It was like, KPH.
On the sign itself.
Yeah.
I remember seeing that, and you still see it on like the speedometer on cars.
Yeah, the red part of the speedometer.
Inside the speedometer. Yeah, there'd be a different,
Yeah, very
version.
useful when I drove to Toronto, yeah.
Yeah, and I used to see metric around the house. I'd be working with my dad on the car, right? And you need a socket wrench, and this one is going to be 5/30 seconds or something. That's kind of small, but
Yeah.
you
You got the
1/16.
quarter inch, you got the...
Yeah, and I use all that, and then we'd go to work on the lawnmower, and I'd bring over my socket set, and my dad'd be like, "Oh no, you can't use that." I'm like, "Why can't I use that? I just use it on the car." He's like, "Because this one is gonna use this socket,
Gotta use the metric.
and then it's got 10 millimeter
Yeah.
socket. Why are the two different sockets? They're both bolts."
Because one was built in China.
Exactly. So growing up in the 70s, our teachers told us that we'd be measuring everything in meters and liters by now. But you look around and we're still buying things here in the United States by the foot or by the gallon. Temperature is still measured in Fahrenheit. You go out get a nice sirloin steak. It's going to be measured in ounces, right? That's what they're going to
You get 12-ounce steak. You don't get a...
You don't get a
0.6 kilogram steak.
No, it's crazy. And deli meat, you're gonna get a half pound of ham, right? That's how it's all done. Even you look at our real estate; it's even all done by acres, right? Whatever an acre is.
That's right. So I guess how did this all go off the rails so quickly? Since the 70s, I guess, is the big question here, right? Why are all of our measurements here in the United States so different than from the rest of the world? I mean, our teachers' predictions about the U.S. adoption of the metric system, none of that came true.
It didn't. I mean, they scared us.
They were like, it's coming, you need to learn it. None of that came true.
I learned it, and it hasn't paid off.
Well, I mean, you're a physicist, so it has paid off.
Okay,
that's true. But not when you're at the supermarket.
I just get more confused. Why don't they use metric?
So I guess that's what our topic of this episode of I Used to Know is. I used to know the metric system was coming. And it didn't quite work out that way. So, all right, it's a story where the U.S. was going to join the world in using the metric system, and how in the 70s there was a big movement to prepare America's youth for the day when the U.S. government would make the big switch to metric and take the rest of the country with it.
There we go. It makes sense that the government is going to be a big part of the story, right? Because we're talking about units and measurements. It means defining the standard, right? And when you boil it down, isn't that what the government is really doing for us? Most of the time, they're defining the standards. They're defining the speed that we're allowed to drive on the road, right? They're telling us how high each of the steps on a staircase has to be in order for it to be within code.
What a dollar's worth.
Yeah, exactly. Even the size of our soda cups, right?
Soda cups?
Yeah, go to Manhattan and try to get like an extra large.
Yeah.
Yeah, you know what I'm talking about.
Yeah, the soda.
You can only get certain sizes. Looking at you, Mayor Bloomberg, ex-Mayor Bloomberg.
Yeah.
Right, doing that. So let's kick off the story. We got to go all the way back to the beginning, all the way back when the standards were first defined, and this happened in France. It was 1670. So let me crank up this Wayback Machine, and we're going to head out to 1670.
Hey, Steve.
Yeah, I know where this is gonna go.
Where?
Yeah. Let me just guess. You want to go farther back, don't you?
Shocker. just once again, just a little further back.
Just a bit. You should just have that on a soundboard, and you can hit the button. So when I ask for the Wayback Machine, you can just say just a bit further back.
There you go.
All right, fine. We're going. We're not going 1670. We're going Romans, right?
Nope. We're gonna go to the 20th. Or between the 20th and 16th century.
That's a little
BC.
Bit. Oh, come on. First of all, it's a wide spread of time.
Yes.
And now
BC.
We're BC.
Yeah, that's pretty far back.
So I want to see where this goes.
I want to go back to where the first measurement standards were handed down by something even bigger than the government.
Bigger than the government. Top of the government is the king, something like that. The chieftain.
Nope. God.
Okay.
That's right.
You go big or you go home.
Exactly.
All the time. Okay.
Because according to the story of Noah, in Genesis of the Old Testament, remember, according to the story, God told Noah to build an ark that was 300 cubits long, 50 cubits wide, and 30 cubits high.
All right. So it's
cubits.
Yep.
So that was the standard, right? And according to the dictionary, a cubit was approximately the equal to the length of the forearm.
Whose forearm?
I guess Noah.
Just a forearm. Noah's forearm.
He was the original subcontractor, so his forearm, right? And so, which is typically around 18 inches or 44 centimeters. And so, I wanted to take us back to one of the earliest standards defined to us, the cubit.
Okay.
In the Old Testament.
All right. That actually made a lot of sense to go all the way back there.
Thank you,
because it's the first standard. Okay. Now, can we please go to 1670?
The machine's all yours.
Oh, great. Thank you so much, sir, for allowing me to go to the French Revolution in 1670. There's a vicar of St. Paul's Church in Lyon, France, Gabriel Mouton.
Very nice.
Thank you. I took 3 years of French.
I took 3 years of Spanish 1.
So next time if there's somebody from Spain, you can get to say the word.
Mm-hmm.
All right. So Gabriel Mouton came up with the idea of a measurement system that's going to be based on the decimal system, right? Makes sense.
Yep.
And his proposed system is going to base length on kind of like the circumference of the Earth and break it down into 1 minute of an arc of the great circle of the Earth.
Nice.
All right. So that's easy, right? The Earth is not going to change. The length of the arc is not going to change, and that's going to be a standard of measurement.
Pretty good constant.
It works. So he creates a decimal-based measurement, and he's going to continue this throughout the French Revolution, and it's going to be carried forward by the French Academy of Science until they came up with a decimalized measurement, like that word, decimalized, based on 1/10,000,000th of the distance between the equator and the North Pole. And from this, they're able to put together a national prototype meter. It's named for the Greek word metron, and that in Greek means measure.
Okay.
And they created that out of this chunk of platinum and iridium.
Okay.
All right. So they got this thing, and now that's the meter. From the meter, all other metric system measurements are going to be derived from this. So that every standard is going to be a factor of 10, right? That's all part of the decimal system. And all that together, you have the birth of the metric system. So meters, millimeters, kilometers. It all comes from the French.
Nice. Well, meanwhile, back at the ranch in England, it's a different story.
Of course.
Right? So you got King Henry VIII and the late 15th century, and it goes until about the 17th century. You've got all sorts of different standards coming about, right?
Of course, because they're so far away from the French. There's like, what, a couple dozen miles across the channel?
Across the channel. Yeah, you couldn't take the train there. So, but basically you've got things like the rod and the furlong and all these furlong. And all these measurements are really coming out of measurements that were derived in the Middle Ages. They're just, instead of it being a different kind of measurement between all the different villages, certain villages make a pact and then more villages make a pact and they get together more and more and more until
just making up stuff.
Yeah, until you're starting to get more of a constant kind of, setup for Great Britain, and you're getting these new standards. And so to really, though, discuss these standards, we have to go to the Weights and Measures Act of 1824, because that's when the British imperial system officially becomes, a standard, right? That's when it's established. The act creates a government standard, and it's based on something they physically had that defined the unit. Like you said, it ended up being like, this is the rod for the meter. So the British government also had physical things that would define the standards of things like a foot, an inch, and all those kind of things.
So they could point to it, and then when they're trying to sell different things or buy different things or commerce is running around, everybody knows how much or how big or how long something has to be.
A constant level.
Okay.
Yep.
All right, so I get it. All right, so the French come up with the metric system, the British come up with the imperial measurement system, and both of them have to refine their standards over time, and it all gets kind of like settled. But now why here in the United States, why are we on imperial measurements?
Thomas Jefferson.
What do you mean Thomas Jefferson?
He said so.
Thomas Jefferson said so.
Yep, Thomas Jefferson said so. As the first Secretary of State, he had to decide which way to go. Do I go the French metric way or the British imperial way? And he chose the British imperial way.
That doesn't make any sense. Everything I know about Thomas Jefferson, he loved the French. He was always over in Paris. He's doing all this Thomas Jefferson...
hanging out with the French, like the Hamilton play says. Yeah.
Yeah, exactly. He was like an ambassador. He's doing all that diplomacy.
Yep. Love their ice cream, like our ice cream episode.
We fought the British. We fought the British for our independence. We broke away.
Yep.
So Jefferson loves the French. We fought the British. What? How? What is happening?
So, well, it has to do partially with the way the meter was measured. Okay, so it's based. The meter was based, when they did that arc thing, they did it by doing a survey in France.
Okay.
All right. So that means that it was really around French survey, French land. So who wants to take orders from the French?
Yeah, okay.
All right. And of course, there's now coming up the French Revolution. And who knows what's going to come out of that. So why are you basing a standard out of something that you're a little new about?
Yeah, it's a little uncertainty.
Yeah.
Okay.
Plus, even though we fought the British, even though we won against the British in the Revolutionary War, who became one of our largest trading partners right after the war?
Was it Britain?
Was the British.
So we fought each other, and then we
had the wood.
Okay.
Right? We had all the supplies they needed.
Right.
So,
And
right?
money talks.
Money talks.
Yeah, okay.
So,
All right.
so we went with the British units. And
right.
so Thomas Jefferson set us on the path of the imperial measurements.
All right. That's how we went.
Are you addicted to classic TV shows? Did you spend the 80s sitting in front of the boob tube? Then join us for TV Tangents, where we examine television of the 20th century with barely any contemporary context. Visit Shout Engine, Apple Podcasts, Google Play, or wherever you get your podcasts, and look for TV Tangents.
So eventually, other European nations would start to get together and look for a common standard, right? And they liked this decimal-based standard, and so they started all adopting the metric system. And eventually, most of the world starts going metric. That is, of course, except for the British territories and the U.S. until about 1970. And Great Britain would start converting to the metric system so they could trade more easily with the rest of the world. And once the British decided, okay, we'll give up a lot of the imperial system, the rest of the world kind of fell in line because everybody wanted to trade amongst each other, right? And I mean, nearly every country in the world fell in line.
The whole world is just...
There's just 3 countries at this time, right now, as recording in 2018, that does not follow the metric system.
Okay.
All right? They are Myanmar, Liberia, and us in the United States.
That's it?
That's it. 3 countries.
Liberia.
Myanmar.
United States.
Yep.
That brings us now to when we're growing up. The United States starts thinking about converting around 1970 to metric.
Yep. Our teachers were telling us everything. Yep.
Get ready.
Exactly. So, but I want to point out that the U.S. was actually thinking about the metric system even earlier than 1970.
Oh, do you want to get the Wayback Machine and go a little earlier?
Nah, I'm good.
Okay,
I'm good. But I think we could just hike there.
We'll just hike. Okay, how far back?
1875.
All right.
That's when the United States was, believe it or not, one of the original 17 signatory nations to the Treaty of the Meter.
There was something called the Treaty of the Meter.
Treaty of the Meter.
Treaty of the Meter.
Isn't it awesome?
We signed off on it?
Yeah. We were one of the first ones to do it.
Over here, nobody does anything in the meter.
I know. Alexander Graham Bell even was pushing Congress. He testified in front of Congress, and he was like, look, we have to go to the meter. We should lead the world with this. We should save money by making everything be the same standard. You know, this is just the way it should be. And we could lead here. We should go that way.
Because he's a scientist, he's pragmatic, and he knows that this is going to be simpler.
Exactly. So, and so as we go into the 70s, we're still trying to get our arms around the rest of the world going meter, right? And so, or going metric. And so Congress passes the Metric Conversion Act of 1975. And its point is it creates a commission, and then its job is to kind of help the United States move us towards the eventual conversion of everything to the metric system.
Okay, so that's why our teachers were on us to get ready for the metric system, because there was actually this official act.
Yep.
1975.
And money and things to push us. There were TV ads. There were, all that trying to push us to go towards the metric system.
Metric is coming.
Exactly. But as we know, we're not buying our deli meats, in kilograms or grams. So what happened? There's a couple of factors that ended up throwing some cold water on us, right? So one of the first factors was actually labor unions.
Oh, really?
Yeah. They were totally against changing because they thought...
Why?
Well, they thought it would lead to globalization and outsourcing of jobs. Because if another country already knew our measurement system, then they could just build stuff right away.
Easier.
Yeah, they didn't have to try to convert things or convert equipment to do our thing. So we would fall in line with their systems, and so they could just build for us.
So our system is kind of like our own unique little language, and it helps us keep everything inside. Well,
actually, that's another way that another argument that was happening during the time. People would argue that, quite frankly, it's like a second language. If we know the imperial system and all of its, quarter, 3/4 of an inch and all that stuff, and we know the decimal system, with millimeter, decimeter, meter, then we could speak 2 languages. So it's kind of like, we're more diverse if we knew that. That was one of the real arguments they said for not changing, right?
Because we want to be more diverse. All right.
Exactly. And then, of course, finally, the big thing was the U.S. people really didn't care to change.
People don't like change.
Yeah, well, they just didn't feel like they should change. They felt part of it that our identity was tied into the imperial measurement system, and they just didn't care enough about it. So by 1981, that commission I told you about was nicknamed the Metric Board. Right?
That was their name, the Metric Board.
They reported to Congress that, hey, look, we don't have a clear mandate from Congress to make this change happen. So, we're out of here. We're done.
That was it.
Close up shop.
You just said, gave up.
We're done. We're done here. We've stopped trying.
So that's why it failed.
So in 6 years, they just said, we're done here.
And it's just like, let it go, drift off into the distance. Everybody's used to the imperial system. Everybody's used to feet. Let's just continue to measure stuff in feet.
Even though the rest of the world is going the other way, that's fine.
That's why it failed.
Yeah, but I want to point out, it really didn't fail.
What are you talking about? I go to the gas station. I get gallons of gas, right?
Yeah.
Explain that. Gallons of gas.
So, first of all, it's important to understand that, you may not realize this, but all of the U.S. imperial measurements, its underlying definition is the metric system, not vice versa.
It doesn't make any sense. So the foot, right?
Yeah.
The very definition of the foot, 12 inches,
is a part of a meter.
is based on the metric system?
Yep.
What?
Yep. A yard is based on a meter. The foot is based on a meter.
No.
The inches are based on centimeters. Yep.
Is this one of those things where you try to punk me in the middle of the podcast?
Nope. In 1893, the United States, in cooperation with the International Bureau of Weights and Measures, right, they officially defined all of our United States units of measurements, like foot, pound, gallon. We defined them all in terms of their metric equivalent of meter, kilograms, and liters.
Seems so complicated.
Yeah. So since 1893,
All right.
the U.S. has been using the metric system. We just convert everything again to our imperial measurement for the public.
Since the turn of the century? So
Yeah.
okay, let me get this straight. I gotta walk through this so I can wrap my head around it.
Absolutely.
All right, so basically what you're saying is we measure stuff here in feet.
Right.
But that's really measuring things in meters.
Yeah. Because it's based on meters.
But we hide the fact that it's the metric system behind it all because we as a people just don't want to believe it's there.
That's right.
Oh my gosh. This just gets crazier and crazier.
Yep. But I will point out, in some cases, the metric system is right in front of us, right? I mean, we talked about the 2-liter bottle of soda.
Yeah, okay. You always get the soda in 2 liters.
Yeah, 2 liters, right? Or gin or alcohol is actually measured in liters too.
All right. Yeah, that's
Right?
metric.
So that's all in the metric, right? You've heard of, I personally haven't run, but I know friends who have run a 5K.
I have seen a 5K.
I have seen a 5K. What does the K stand for?
Okay, kilometer.
Kilometers.
Yeah, okay.
Right? Or the military. They say they're going to go hike 6 clicks.
A click, yeah. That's a military distance. Click.
Yeah, click. With a K. It's not click with a C, it's click with a K.
Click with, so that's kilometer?
For kilometers.
Oh, okay.
Yeah, exactly.
Well, that makes so much more sense now. I've been watching these movies. They're like, it's 6 clicks out.
Yep.
Kilometer.
Yep. Kilometers. And everything's scientific. It's all metric, right? I mean, I was studied meteorology, right?
Yep.
My idea of measuring, the atmospheric pressure is not in inches of mercury. Sure, I grew up with inches of mercury, but because of my scientific training, I have to see everything in millibars.
Millibars, right? Because
that's just how. If you looked right behind me, in fact, there's a little pressure gauge there, and if you look at it, you'll see it's in millibars. It's not in inches of mercury, because I actually can't think in inches of mercury anymore.
Because you were trained as a
I was
scientist.
trained as a scientist to think in millibars.
Metric system is all part of science.
Yep. So, all right. So, hey, I have an idea.
Yeah.
You want to play a quick game?
Yeah. I love games. Let's do it.
Okay. All right. So here it is. All right. You have to tell me if I'm going to tell you a measurement, and you're going to have to tell me if it's metric, imperial, or imposter.
You're going to have made up measurements?
Yes.
Okay. I don't know how I'm going to do on this, but okay, fine.
Okay. Here we go.
Go.
All right. I'm going to give you through. We'll start off with an easy one, right? Acre.
Acre. Oh, we talked about that at the beginning, and that's definitely imperial.
It is definitely imperial,
Yeah.
right? What's
Ding.
the metric
The metric?
version of an acre?
Hectare.
Hectare, yeah.
Hectare.
Yep, exactly.
Okay.
All right, ready?
Yeah.
Ton.
A ton. A ton is definitely imperial.
It's a trick question in a way because it's actually metric if it's a TONNE because that's a ton in metric.
That is tricky.
Because officially, a ton, TON, in the imperial system is a short ton or a long ton.
So you got a short ton, long ton, and then tonny.
Right.
Okay. Good.
Exactly.
I got it.
All right. A cauldron.
A cauldron. That's made up. That is totally made up.
So it's sort of old imperial. It actually was a real thing.
What is a cauldron measure?
Apparently
volume?
Yes. So apparently it's the equivalent of, well, it's volume and weight. I think it's a combination in the old imperial ways.
Okay.
I read that it was related to one cauldron was equal to 36 bushels of coal.
That's a cauldron. So it's not like a witch's cauldron.
I guess
a
kind
cauldron
of, right?
is, cauldron is
it's
big,
big.
right? Wow.
Yeah.
Okay. Cauldron. Who knows?
Okay. A boulder.
A boulder. A boulder. Okay. I know in England they measure stuff by stone.
Okay.
So a boulder's going to be bigger than a stone. I'm going to go imperial.
It's imposter.
Oh.
But you're right about the stone.
I should have gone.
You're right about the stone, which is about 14 pounds or 6.3 kilograms.
I'm trying to read your eyes. I'm trying to figure out if you're
My cold data.
if you're looking to the right when you say something, if you're going to lie to me. All right, go ahead.
Okay. A Langley.
A lie. That's an imposter.
Nope, that's real.
Oh man, this is so hard.
Yep.
What is a Langley?
Although it's real and it's an imperial thing, it's a measure of solar radiation, as in the scientist Langley.
A Langley is solar radiation. It's not the CIA headquarters.
No. Well, yes, it is, but that's the guy, right?
Okay.
The scientist, right? So it's a measure of solar radiation.
Really?
Yep. Okay.
Okay.
On that same topic, in
Yep.
Einstein.
And Einstein. Jesus, I'm so bad at this. And Einstein is fake.
It's real.
Ah.
Yep.
What is an Einstein?
And it is basically it's also metric. It's a measurement of 1 mole of photons.
a mole of photons?
I know. What
are you
we're
talking
talking Einstein weirdness anyway. So
Right.
here we go. One of the quotes I read was that think of it in terms of micro Einsteins per second per square meter is the way you would describe it.
Oh yeah. Why don't you just say that? Oh my gosh. I have to go back to school. Oh my gosh.
Yeah. So that's our metric story.
Oh, what are they? I got 1 out of 6.
I think you got 2.
I got 2.
You got 2.
Yeah,
Of course, one of them was acre.
I got hectare.
You did. That was pretty good. That
also counts.
Yeah. So you got anything else?
Yeah. I think I got other stuff. Problems of having different units on teams that are working together. It tends not to work out so well, right? So let's take, for example, way back when they had the Mars Environmental Probe sending this satellite out to Mars.
Mm-hmm. I don't remember it landing on the Mars.
It kind of did.
Yeah?
Did. Because Lockheed Martin, I think, they were working in the Imperial system to put all their code
Based in the
together.
US.
NASA is off doing their part of the project, and they are starting to code everything, but they're coding in the metric.
But they're
system.
US. But yeah, they're scientists.
But they're scientists.
Mm.
So then they had to bring the 2 pieces of the satellite together, mesh together the
numbers.
the software, and turns out they launched this probe. It starts flying to Mars, and all the numbers get all goofed up because some are in imperial and some are in metric, and the probe just gets too close to Mars and just
burns up into a fiery ball. And
done. And everybody's like, oops.
That's a really expensive oops.
Yeah, before we do this again, let's all agree. Metric system. All right, and then there's another example I came up with during my research here. So there was a problem once. I don't know what airline, but the airline pilots, before they took off, they had to calculate how much fuel they needed, and they had to do that all by hand because the automated system that they usually have for refueling, all that was down. So they're on a pad of paper, they're calculating how much fuel they need, and they're calculating how many kilograms they're going to load up into the into the plane. Well, it turns out they hand the number off to the guy who's going to go and fill up the plane. And that guy looks at it and he's like, okay, I'm going to put this many pounds of fuel into the plane. And pounds, there's going to be less than the kilo. So they take off and they get about halfway because it's about half.
All of a sudden they're like,
And they're like, nope.
what happened to the gas gauge?
There's no gas. So they had to emergency land halfway through the flight. So whether you choose imperial or metric, it's important.
Yeah, especially for those flights to Hawaii.
Because we're like, okay, everybody, reach underneath your seat.
Remember that thing we told you that could be used as a flotation device? You're going to be using it today. Yeah, not such a good plan.
So how about you? What did you come up with?
I got something.
Yep, you always do.
And it's about how the kilogram has just been redefined.
Just redefined. We just went through this whole thing about how all the standards have all been set. There's this meter from France.
Yeah.
They set
Platinum
it all
and
up. Iridium.
Iridium.
And everybody's got everything written in law. We know what these standards are.
Yep.
What are you talking about?
Well, so not anymore.
Of course
It
not.
has changed, and it has changed as of November 16th, 2018. Yeah.
That was like last week.
Yeah, I know, right?
Really?
Really. Yeah. So basically, 60 nations, including the U.S., gathered in Versailles, France, right? And they decided it's time to change the definition of the kilogram.
Why would they fix what's not broken?
Well, so it is kind of broken, sort of, right? So, all right, the kilogram was originally defined by this chunk of metal, right?
Yeah.
It's a cylinder of, shocker, platinum and iridium.
Yay.
Yeah. So it's a cylinder. They've been protecting it and, it under glass, keeping it safe. There's like 3 copies or 4 copies around the world. NIST in the United States have them, everything, right? But, everybody's trying to keep this basic, perfect measurement of a kilogram just perfect.
You got to protect it.
You do. Because
right.
every measurement on the planet, even the United States, via the pound, depends on this thing.
Okay.
Right? But it can never really be perfect because everything decays. Right?
No, that's true.
So since they built this thing, this cylinder, it's lost an eyelash worth of weight.
So the kilogram is lighter than it used to be.
Yes.
Even by just a little bit.
Yep. So your cereal box is smaller.
Great.
Yeah. So, but they decided we can't go on like this. How can we ever go on like this? Things are changing, and you can't change that.
Yeah, you gotta be fixed.
Right. So they decided to prevent this from ever happening. They redefined the kilogram so that it's now defined against a fundamental feature of the universe.
Oh, that makes sense. It's not going to change.
Yep. So they basically took a figure from quantum physics known as Planck's constant.
Oh, I know Planck's constant. Yeah, sure.
And it basically, though, it describes the smallest possible unit of energy, right?
Yep.
And since Einstein created an equation that relates energy to mass,
yep,
we can define its mass by a universal energy constant.
Key word being constant.
Yes, a constant of nature.
That's not going to change.
Not unless the universe itself changes.
Better not.
So I don't think that'll happen within the Earth's lifetime.
All right.
So now the kilogram will never change. And it's going to be just like the meter. Because the meter will never change as well. Because back in 1983, they redefined the meter. And they redefined it against the speed of light. So
okay.
they have it basically going after how far light travels in a vacuum is the definition of a meter, like how many seconds it takes to travel.
Gotcha. Because speed of light is a constant.
Yep.
That's not going to change. Planck's constant, key word. That's not going to change. All these things are now rooted underneath our definition of the meter and the kilogram. That makes so much sense.
And if you think about it, it sort of even unlocks this concept to something even bigger and grander than anything we started with. Because now, by putting things to the universal constants, anyone can measure it. You don't have to go to a government agency and say, help me define if I'm compliant to a kilogram.
Yeah.
Or help me define, am I really compliant to a meter? You know the speed of light. You know Planck's constant. Anyone in the planet now can define perfectly whether they have a real kilogram or they have a real meter.
That's so much better.
It's like open source.
Yeah, you don't have to go open source. You don't have to go and lift the glass bell jar off of the hunk of metal to find out if you're good. Oh man, great science.
Yeah,
go science.
Yeah, there you go. So you good?
Yeah, I'm good.
Great. Well, so I guess that's how I used to know the metric system was coming. I hope you like this podcast of I Used to Know. Did you know we're on iTunes, TuneIn, iHeartRadio, Stitcher, Google Podcasts, Spotify, everywhere you can possibly get your podcast fix. And if you did know, hey, do us a favor. Go out there to your favorite podcast player and give us a rating.
Yes, that'd be good.
Yeah, we love ratings. Ratings help people find us. And also, if you have a suggestion, hey, come visit us on our Facebook page at I Used to Know with the number 2 on Facebook. Or you can hit us on Twitter with I Used to Know Pod, again with the number 2, and tell us what you're thinking. We would love to hear from you. We'd like to research something for you if you find something interesting you want to that you used to know.
All about the research.
Exactly. And don't forget to go visit us on our homepage at iusedtoknow.com where you can see our Pinterests. Thanks always to our amazing Stevie Jump for our theme song. And thanks for listening. 3s and 8s, everybody.
Talk to you soon. Bye.